Hello everyone, this is Anshuman Srivastava and you are on Process Before Equations. I'm a process engineer with around 8 plus years of work ex in the industry. If you have ever looked at an engineering design, you might have noticed something odd. Pumps are bigger than calculations suggest, heat exchangers have extra surface area, pipes look larger than necessary. At first glance, this feels inefficient, maybe even wasteful. So the obvious question is, if calculations say this size is enough, why do engineers deliberately choose something bigger? Now, the answer has nothing to do with bad design and everything to do with how the real world actually behaves. Now, most engineering calculations are based on assumptions. They assume perfect data, steady operating conditions, clean equipment, and no mistakes. In other words, equations describe an ideal world. They are extremely useful, but they don't see uncertainty. And engineers know that real plants never operate in ideal conditions for long. In the real world, things change constantly. Feed composition varies, equipment fouls and corrodes over time. There could be drifts in instruments. Operators sometimes make mistakes. The most common thing is plants age. Startups and shutdowns introduce even more instability. Now, engineers don't design for one perfect moment, they design for years of imperfect operation. Oversizing doesn't mean engineers are careless, it means they are cautious. Oversizing absorbs uncertainty, it provides flexibility, it gives operators room to respond. Think of it this way, oversizing is not inefficiency, it's insurance. Now, when equipments are sized with no margin, problems don't appear immediately. Pumps start operating their limits, heat exchangers fail to meet duty during fouling, control valves hit their limits. These systems don't fail dramatically, they fail quietly through poor reliability, frequent trips, and reduced plant availability. Now, oversizing usually increases your capital cost slightly, but undersizing increases operating cost dramatically. Downtime, lost production, maintenance, and safety risks cost far more than a slightly larger piece of equipment. Engineers don't design for maximum efficiency, they design for systems that survive real operation. The common misconception, oversizing without thinking is a bad design, but oversizing with intent is good engineering practice. A system with no margin is fragile, and fragile systems don't last in industrial environments. Designs that barely work on paper rarely work in real plants. Engineering is not about chasing perfection, it's about managing uncertainty. Safety margins exist because experience exists. Oversizing is one way engineers respect reality, not fight it. That's how real engineering decisions are made. Thank you.